Welcome back. In the previous session, we have created a document feature matrix from text from corpus from Quanteda corpus, and then we have seen the head of the test document feature matrix and the head of the trained document feature matrix data frames. We can continue from there, and we can see some of the key features of these test and train data frames. Let's say you can see the dimension of the train. It actually works the same way as a data frame, so you can see the head, you can see the dimension. Actually, the head gives you the dimension also, because it gives you the number of features and sparsity, and but if you look at the dimension, you can have this. We have 614 observations, and you have 9,938 features. So this is, it's kind of, in text data, if you are working in some kind of data frames where you have more observations than variables. Actually, it's the rule of thumb is like if you have 20 variables, like if you have one variable, it needs 20 observations. That's a rule of thumb. And if you have 20 variables, that means you need to have 400 observations. So that's not an easy number in this case. So we have about 9,938 variables or features. In this case, they are called features. I think that's a language they are very common in the machine learning literature. But in epidemiology, you call them variables. But they are features. They're the same. Or you call them features or characteristics, or independent variables or explanatory variables, and so on and so forth. So in this case, you see the data is very short and fat. So it's really short, like means the number of observations, they are small. But if you look at it horizontally, that means it's really wide data frame. So, and then at the same time, you have lots of sparsity, lots of zero values for this data frame. So the algorithm that let's say if you do linear logistic regression or something, then it may not work in this case. So you need to try a different. That's why I mean this kind of data. Like a small number of observations but a large number of variables is very common in genetics and text data studies. So usually you have this kind of short and fat data frames. So once let's see also actually Quanteda also gives you, it gives you like a number of features, but also you can also as you see, we have seen the dimension, we have seen the head, but also you can also number of features. Okay, in normal data frame, you can use number of columns or number of rows. In row, you can also use in row to know the number of observations, or you can see number of columns. But Quanteda gives you a nice function to know the number of columns or the number of features. They call it n fit. And let's say you can see the number of features for test data frame. So you see 6,348 observations. If you remember, we have about for this number of this was the dimension, that means 9,938. If we change this to n fit, so that means we will see this much number of features. So you see 9,938 as exactly we have seen it in the dim function. Yeah, so that's how you do some basic understanding of your data. So we have already created our document feature matrix. We have seen some of the heads and the dimension. The next thing is, I think, visualizing these features. To visualize, we can use same like WordCloud as we did in the previous session using tidy text. In this case, actually, WordCloud is actually much easier in Quanteda, Quanteda gives you a package called, a function text word cloud. So that will be what we need. So, and then we load this R color brewer as we did last time, and then we define our pal, and then we call it this brewer pal. I think entirely text you don't need to define, you don't need to load this R color brewer pal, but in the Quanteda you need to define it. Let me just use 5, like 5 different color labels. And then we can use dark 2, that's what I need. And then after that, so let me run these 2 lines. Then after that, I simply use the word for the word cloud. I simply use this text plot word cloud. Text plot word cloud. This is what Quanteda gives us. This nice package. So for that, what you need is you need the document feature matrix, and you use the mean size. Then that's the mean size in the number of count. Actually, you can also define the mean count, maximum number of words. Yeah, and then the rotation and the type of the graph, whether it should be in square or in circle or whatever format, or in a sphere. You can simply define that. So for that, let me just define the twin document feature matrix, and then let me just use the mean count. Let me just use 50 or maybe 40. Let me try 40 number of words, and then the maximum. That means 40 is the mean, the number of times the word appears in a document. So in the total number of observations. So if the term appears 40 times, then it will be it will appear in my word cloud. Then the maximum number of words that I want to visualize, maximum words is because in your word cloud you cannot visualize, I don't know, 1000 or something words, but you can choose how many words can fit in your actually in your word cloud, in a circle or in a square or whatever kind of format you want to fit. So let me just use mean count is 40, and the maximum words that I can fit is 400. I just want to visualize 400 words, and these 400 words should appear at least 40 times in all of our observations. So that's what you need. This may take a little bit of time until it put everything, and let me get ready so that my it appears in the viewer, or I think in the plot section. Then we will see how our plot looks like. So that's how our plot looks like. It seems my again the viewer didn't work, but that's how this the words look like. So this seems to be a very, maybe I reduce the number of times. Maybe this one, maybe let me just use 200, and let me just use 50 and see how this plot looks like. But I just don't know why this didn't work. So the brewer pal, it was supposed to work. So our color brewer and the pal dark 2. So I don't know, for some reason it didn't work. Yeah, this color should not be the same. It should be different kinds of colors should have appeared. Let me run this again and see if there is any difference, but it doesn't seem to differ. Yeah, so now it looks like this. So you see this is our word cloud. Okay, no, I didn't define something yet, because I need to define that color. Sorry, color, that is the color pal that I want here. So I need to give it this, yeah, color pal. So now it should appear now. All the different levels should be, yeah, now, yeah, so good. So now it's coming on the terms. let's give it some time, and yeah. My R is a bit busy. Okay. Yes, so that's how my my WordCloud that we did with Quanteda package looks like. So let's see, you know, this the thickness, I mean the how fast these words are written depends on how frequent these words are. So let's say, you know, the most frequent words, they appear larger. So patients, for example, it's kind of as big, and then you have SARS is also appearing as big. And then you have COVID. Then it goes like this. And then you have infection and all these tiny terms. Maybe we can in only visualize, I don't know, 100, and this will be more visible. Let's try again. Or maybe I can change. Yeah. So in this case, you see, it's more readable. So maybe let me go back, and yeah. So this will. It's kind of a little bit better, but since some of the other terms, they are really sparse and they are not very, they didn't commonly appear. So these are the most common words that appear in our text data. So this maybe, I'm not sure you can stratify it, because we have two different variables. Like you can, I'm not sure. Maybe we can check whether you can stratify by, you know, by like COVID. This is for COVID, because COVID and SARS, they appear in one visualization. But maybe you can try to stratify it by this status, whether it's COVID or SARS. Let me just ask Quanteda for help and see if they have any stratifying mechanism. So it doesn't seem to have any. No, doesn't have any stratifying variable. So what you can do is you can select your data frame by that status, and then after that you can plot side by side. Yeah, and maybe we can also try for the test data frame and see if there is anything different from what we have observed in the test data. So they seem to be nearly the same. So now it looks like this. Again, it's the same as the training data. So at least the terms, they in the previous data we were also seeing like COVID and SARS to be yeah, it's the same. So maybe the next one we have seen. The next one would be about prediction. So prediction and training machine learning model, and I think for that one we will have to proceed next time. But for now, so we have seen how you create, how you make this change test corpus, and from corpus you create your tokens, and from tokens you remove the stop words, you remove the punctuation, you remove numbers, and you remove custom stop words, and then finally you create your document feature matrix, which is kind of like a data frame, but it's a bit different because it measures the sparsity, and also they have kind of similar nature with data frame, but you can also convert it in data frame using another function in Quanteda. And then after that, what we did is we have seen some visualization using this text plot word cloud package function from Quanteda again. Yeah, and for the next one we will see prediction. We will train a machine learning model. So the first thing what we need is we will use naive Bayes and support vector machines using Quanteda again, but Quanteda has an extended package called Quanteda text models. If you don't have it, I do recommend installing it if you are doing text analysis, or if you want to try how Quanteda text models actually it's a very super fast, and yeah, I definitely recommend installing it and trying. So and then we'll train again other algorithms from ETN71, for example SVM, and then from GLMNet we will train others like regularized models. That's what we will do in the coming sessions, and for today we're finished, and I do recommend again to suggest the channel to people who might be interested in this kind of analysis, or subscribe. I will also have more videos coming up in any other topic in statistics, epidemiology, and maybe text classification or whatever. Yeah, I will have some more videos coming up. So in any case, it may be good to subscribe, or you can also add a comment and let's say, okay, make a video on this topic. If you are running into certain analysis and you want to make a video on it, then I can have a look, and if you have worked on it, then I can simply jump in and make a video and I can share it. Yeah, having said that, thank you for attending, for your attention. Thanks.